His major research areas are functional analysis, numerical functional analysis, mathematical finance, etc. So I welcome you, sir, to this program.
Very good morning to all of you. First of all, I would like to uh, thank the SPI College, uh, especially Dr. Ulasa, Dr. Shine, the head of the department, and the principal, Father Raju, for giving me an opportunity to speak on this particular topic. Of course, as our head of the department mentioned, I will be talking about the role of mathematics uh, in the 21st century, the research and career opportunities. I understand that this particular webinar is addressing to uh, the students who have completed plus two and would like to continue for their higher studies, especially in the mathematics area. So when we are talking about opportunities, the career opportunities point of view, traditionally we know that after plus two, the people may opt for engineering or medical. Then the other two extremes are science and commerce streams. And we know that usually if you look at the past history of they have the collaborated with other national and international internship programs, publications, libraries, sports recreations, and facilities. So these are the important facilities in IISER because IISER has been started with a specific focus on promoting scientific research in the country, whereas IITs are traditionally for the technological research. And how many IISERs are there? There are 7 IISERs, one in Pune, Petta, Mohali, Bhopal, Thiruvananthapuram, Tirupati, and Berapur. And if those who are interested can visit that websites. And generally, all IISERs offer, I mentioned, the courses in all sciences, especially mathematical sciences. All IISERs offer the courses in undergraduate and postgraduate and the PhDs, and students are able to get the undergraduate programs in IISERs and IIMs. And the major chunk of the students normally will go to colleges and they get admission in BSc. And for example, if I don't get a chance in IISERs or IITs in BTech or business program, naturally, if I am interested to pursue a career in mathematics, then I may opt for a BSc programs in very good colleges. And after that, what I will do, whether I can study in very good institutions like IITs or IISERs, it is possible. So that is what the integrated PhD programs are in place. For the integrated PhD programs, the requirement is someone who passed this BSc course. So if I want to pursue a research career in the mathematical discipline, then what I will do that I can complete my BSc, then I can opt for the integrated PhD program, which will give me a master's and PhD after the completion of the program. So the eligibility requirement is a degree in a BSc degree in mathematical science with a minimum 50%, 55% of rank in the JAM. And what is the salient features of this program? So across all the IISERs have this opportunities, and uh, so of course selection will be based on the interviews and the written test, and they will be provided the scholarship 10,000 rupees per month for first 2 years and 31,000 rupees after that, and will give teaching assistantship for this kind of students. And as I mentioned earlier, MS and PhDs on completion of the course. So again, the limited number of opportunities for this kind of programs. If someone wants to further continue after BSc, if I don't get a possibility to study this integrated course program, I can go for other programs. For example, an MSc program in mathematics. For example, SB College offer that, or other affiliated colleges offer. So I can pursue my career in that stream itself, MSc programs, and then I can go for a PhD programs. And of course, the eligibility criteria is a master's degree, and or they have a minimum qualifications in qualifying with the CSIR, GATE, or INSPIRE PhD, or National Board of Higher Mathematics, JRMS. And so these are the ways one can pursue if you want really interested to pursue a research career in mathematics. So now the question is why mathematics? Most of this talks is based on my experience, because what I will be talking about from what I have experienced throughout my career. And as a student, I was always thinking about what mathematics can offer to the society. Traditionally, we were thinking that when I was a student, then of course I will have interest in mathematics. Our we may not have the guidance now. At present, you can see this seminar is SB College is organizing, or state government usually offer the career, and many other opportunities are there to understand what kind of careers available after the +2 examinations. But 20 years back, or there was no such facilities. What we will go ahead with our own performance. If I take BSc, then I will go for MSc, then probably MPhil or PhD. Like that, we were just moving ahead with whatever is available at that time. The situations have completely changed nowadays. So, this mathematics, what mathematics can offer, or what is the significance, what is the role of this mathematics in the modern science? That is very important. That has been drastically changed for the past few decades. So, the questions before us is why this mathematics? So I will be briefly talking about this one, why mathematics and the relationship between the mathematics and industry, and what kind of research generally happens in the area of mathematics, and some of the examples which I will like to refer based on my research part. Now, question is why mathematics? The mathematician's point of view, we know that many people prefer to opt for mathematics. The reason which we know that people think that mathematics is a very difficult subject, so they will opt other subject for them. Because of that nature, there are very limited people working in our country or globally. That means the dearth of mathematicians in India. And that is the same reason that the US governments like that they introduced the STEM program. Mathematics has a very important role they have given as part of the initiative. Although we know that the mathematics is the queen of science, but people fear to marry this. Right? People think that it's very difficult, and they may be thinking that if I opt mathematics, what I will get, what career I will get it. If I take a BSc or MSc or a PhD, are they only the teaching jobs? Tradition, when I was a student, I was thinking only that point. Or if I do a BSc, MSc, then I will get a college job. Then I can be a lecturer. That's all I was thinking at the times when I was studying as a student. But later I realized that mathematics can offer many, many things. A mathematician can be a better scientist compared to a physics or biologist or a chemist or a computer scientist or an economist or a financial expert. The reason is many things. Because the the mathematics point of view, as I mentioned, what career in mathematics can offer to me if I pursue a career in maths? This is what one of the survey conducted by a US agencies, they found that the top highly paid job, 50 highly paid jobs in the world require rigorous mathematics knowledge. It's not that simple mathematical knowledge. Rigorous mathematical knowledge is required for getting the top paid jobs in the world. Why it is like that? So how or why mathematics is powerful and demanding? The reason is something like when we add the computing to mathematics, when we add computing to mathematics, then mathematics will be more powerful than any other subjects. I have experience. I was a placement of high demand compared to any other engineering. But what I experienced was that the maths people, maths and computing people, have the equal priorities like a computer science. So that is what the demand in the industry. That's what I was talking. Mathematics and industry. Why the industry prefer mathematicians? The simple reason is their ability. So what is special about mathematics? Why there is a difference? So I worked in the industry. I I could work in the industry because of my mathematical capability. When I was a student in IIT, I was thinking about it. Or why only the engineering graduates people get? Why can't me? So there I understood that when I add the computing power to the mathematics, especially if you are looking at the industry point of view, industry require output, or maybe in terms of a product point of view. That product, someone has to design it, someone has to develop it. And if I have simple mathematical knowledge, I may be able to do something, but I cannot make it as a product without adding computing to it, without programming things. I cannot do that. So the mathematician's point of view is their capability, their logical thought, their reasoning capability. They are able to think in a different way. Their reasoning capability is one of the important aspects. Second advantage of a mathematician is that they will be able to formulate the problems in a way in which allows for computational decisions. And when we try to formulate real life problems, we have to translate. That's what the mathematical models comes into the picture. A physical phenomena is transformed to a model perspective. So, but when we are trying to design a model, we need to make certain kind of assumptions. And when you develop that models, or whenever we are able to make that physical problem to a mathematical problem, whatever the deductions which we can make out of that assumptions, that mathematicians will be able to do it. And they will be able to use any advanced concepts. So that is what the industry people prefer in mathematicians. And that I myself experienced. Because of my mathematical knowledge and computing, I could go to a software industry and okay, so I could go and work over there. And and what are the industries where the advanced level of mathematics is applied? Many industries. Traditionally, these industries are okay. Chemical industries make use of mathematics. Oil explorations, where in which you have to identify the oil field, mathematical models are used. Medical imaging point of view, the image reconstructions, the mathematics models are used. Microelectronics, nanoelectronics sectors, mathematical models are used. Information securities, mathematics is used. Communication network, mathematics is used. Entertainment and the software industries, mathematics is used. Financial and banking sectors. So many, these are all a few areas where in which the mathematics is heavily used. But if you are looking at the research perspective, so, we understood that the industry want the mathematicians. Earlier, when IISER started in 2008, the Infosys people told me that we want good mathematicians for public. So they cannot. So we should have an interest to look into new areas of development, new techniques. Then a mathematicians can certainly can dominate in that field as well. And looking at the research perspective point of view, and it is one of the very inexpensive areas of. You look at any other disciplines of areas of science, they need a heavy investment. They require labs. They need instruments, crores of work instruments are required. Then only they can do state-of-art research in that scientific area. So, but mathematics, you don't require that one. You need a paper and pen, or you may require a computer. Your office always follows you. It's a 24/7. So it is a so mathematics research point of view, it is a very inexpensive areas of research. And of course, if you are looking at the area point of view, one may look at algebra or analysis or applied mathematics for computation, many areas of. And if you are looking at the research in India point, I already mentioned that a dearth of mathematicians in the country and also global. What kind of before going to that, some of the research areas which I just want to mention, especially for analysis and applicable. One of the areas, in fact, I pursue, I basic my area of research is functional analysis. Then I have expanded into different areas. Could be many areas. It could be functional analysis, harmonic analysis, complex dynamics, or partial differential case, control theories. stochastic theories, or finance, mathematical biology, or algebra and applicable could be number theory, linear algebra, commutative algebra, representation theory, cryptography. Topology perspective could be algebraic geometry, differential geometry, category theory, data science, graph theory, machine learning. And all these, some of the areas of, I have a lot of areas are there. I just highlighted a few areas for the research here. Now, if you are looking at the research in our country point, we know that the India is the second largest country in population in the world. It accounts around 80% of populations. But what is the contribution of the science, especially in the mathematics, in the area of research or research contributions in the world? We can see that very minimal contribution in this area. There are research contributions in other disciplines, especially we are looking at this graph point. Or the if you are looking at the mathematics point of view, you can see that contribution is very less. For other areas, you can see that their contribution is much higher than the mathematics, and the number of publications coming out of the Indian mathematical research. A lot of research is there. I mentioned here, if you look at the point number 13 over here, you can see that hardly 2% research contribution. So Indian mathematics is, I could say that is poorly performing. The contribution is hardly 2% to the global. Hardly 2%. And if you are looking at the number of research papers coming out in the top 1% category of journal, it's, if you look at the 8 point of view, hardly 150, or within, maybe the latest one could be less than 200 research papers coming out from the mathematical community. So the research has to be emphasized. More research, more people should come forward for research. And as I mentioned earlier at the beginning of the talk, there are various opportunities to pursue a research career, even after BSc or MSc. We have a lot of opportunities, especially if you are looking at after BSc, someone can write JAM, or after MSc, people can write other research fellowship. They can get opportunities in India, especially Indian institutions, or if they write GRE and other examination, they could get an opportunities abroad as well. So some of the areas which the mathematics interest point of view, which I just want to mention over here, is one of the areas people do the research, coding and decoding, or more generally it is called the cryptography point of view. We know that we've sent the messages, like WhatsApp message we send, say that it's encrypted message, right? So when I am sending a message from one person to another person, no other person should see that message. No one will be able to interpret or infer what kind of message I am sending to other person. And this is actually a simple mathematics, which we know that, for example, I just want to send a message that it can be done. If I send directly from me to another person in the same format, others can read that message. But if I can code into some other language, and the receiving person is able to decode that one, then no one can see that kind of message. And one of the simple methodology is ASCII code. ASCII means that American Standard Code for Information. So we can translate this into a different format. The different format is which I have put in a vector format here, 7384, like that I have put it over here. So, so what actually happening here, when we are sending a message from a source to a destination or a sender to a receiver, it is like a function or it is a machine, right? What a machine require an input and it will give output. We can think of this sending messages and receiving message in that fashion. So that means something is acting in between a sender and a receiver. And that machine, that's a machine. And the mathematical point of view, probably the students like you, so you might have seen solving a system of equations, Ax is equal to B. So your idea is like finding X from the knowledge about A and B. Or if you know X and you know A, then you can find out B. That means if my message is X and if I have a model A, that model can change this X into some other language, then that is nothing but B. And that B, the receiver will get it and he has to decode. So if we are looking at the mathematics perspective, it is like a linear transformation. Linear transformation, probably Tx is equal to Y. People might have heard about it, A or Ax is equal to B. So here, actually, if you have Ax is equal to B, when we are trying to solve a system of equations, if you can get, you might have experience of that. I can get a X provided A is invertible. Right? If A is invertible, then X is nothing but A inverse B. So when I am sending a message from me to another person, if I can ensure that that model or nothing but the matrix here is invertible, then the receiver can decode it by inverting that. That's what this coding and decoding concept works. That means what I will do that I take this, it can be done into an ASPIRANT. He will apply back this, he knows that secret code A, that matrix, he knows it. That's what armies and all the people used earlier. And he will be able to decipher that code from this information. So that is the simple application of mathematics. Of course, more advanced level is if you look at the cryptography research point of view, RSA systems and all those things different, where the lot of mathematics peoples are used. Their number theory capability, that's what number theory and cryptography is very important in the IT sector point. Another examples which I just want to mention here is cancer. So you know that earlier when we were studying for the undergraduate programs in BSc, or when we are studying the class 12 level for pre-degree study, there is a demarcations between the biology and the mathematics. At that time, it was called the second group. First, if someone want to take engineering or mathematics, take first group, second group. Like now also it is available, but slightly has changed. Nowadays, the students has opportunity to take both mathematics and biology at the +2 level itself.
Sir, excuse me. One thing I want to
Yes,
clarify.
yes.
Sir, are you presenting something on the screen or do you have any presentations? To,
Pardon?
do you have anything to present? Are you presenting something or somebody is speaking?
I am presenting the screen. Are you not able to see?
No, no, you are not presenting.
Oh my God!
You
I was
haven't.
presenting the slides only.
Okay.
You are not able to see that.
No, 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 we are not able to see your presentation. So you have to start presenting
Oh my God!
your meet
Once again, let me
window.
see whether you are able to see my.
Present now. You have to use that option.
Are Are you able to see now?
Yeah, yeah, now you have started to present.
Right,
Thank you, sir.
right, right.
Thank you.
Okay.
Are you able to see now?
Yes, 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 yes. Right.
Sorry. Thank you.
Oh, sorry. I was thinking that you are able to see my PPT. You are able to see my PPT now, right?
Yes, sir.
Okay. Okay. So the second point which I was mentioning is the cancer. So traditionally, the biologies are segregated from the mathematics, but modern science, it is not. So modern research is more interdisciplinary in nature. Biologists cannot ignore mathematics nowadays. Earlier, people were not using that. And in fact, as I mentioned earlier, a mathematician can be a better scientist than a biologist as well. Only thing is that he requires an interest to pursue that research. So if I say that curing cancer with maths, no one will believe it. But modern research is that the physicians, the medical practitioners sit with the mathematicians and try to understand how the cancer growth is, how the treatment methodology can be implemented. Or you just take our coronavirus, right? The infectious disease modeling. It is nothing but mathematical models. It's nothing but the differential equations model. It is used for the predictions, how the coronavirus is affecting or how it can be generated or how many times it is affecting. All these things, infectious models, spread of this one can be modeled through the mathematics. So coming back to the cancer point of view, this is one of the research area which I am just doing it. So the cancer growth can be modeled through a differential equations. It is called the logistic model, where you could model the growth of the cells. So cancer is a deadly disease, right? It's explosion of the cells, and this can be modeled through mathematics. And there are various models. It could be in this particular model. Of course, it is the analytical solutions can be derived, but these are linear models. There are where one can apply the highly not linear model, where in which one may not have a closed form solutions. Rather, one have to go for a numerical schemes where I could come out with a solution for that non-linear models. Now, when we are looking at the cancer research point of view, we know that chemotherapy is one of the techniques used to cure the cancer. Right. And chemotherapy point of view, which we know that someone who has, we have seen even many of the people experience, undergone that kind of chemotherapy. That's once if you apply this chemotherapy, our body become weak, and that means the our normal cells also, when we apply this medicine to our body, our normal cells also get damaged. So that is what, how to, so after 6 months, if we are lucky, we may survive it. Otherwise, it could be lead to a fatal death. So although chemotherapy is one of the, there are other therapies as well. But but traditionally it is one of the famous treatment protocol used for treatment of the cancer. But some of the problems which my research team is looking at now, if we apply the chemotherapy treatment to the patient, how you can administer the medicine in such a way that the normal cells can be preserved at the maximum level, and at the same time, this medicine can kill the tumor cells.
Hello.
That's one of,
Sorry to interrupt. Sir, the slide is still in 20-second slide.
20 seconds slides. Are you able to see that this one? Which one you are able to see now?
Another slide is 20-second only, that coding and decoding. Now it's mathematics of cancer.
Good. Okay. So this is the, because I meant for the slide mode, probably that may be the reason that you may not be able to see that. So now, if you are looking at this problem, this is one of the research areas people are, that means the mathematics and the biologies are not segregated, rather they are complementing each other for the modern research. It's one of the areas which mathematics is applied. Another area is computerized tomography. We know that the CT scan, we might have, some of might have gone through this one, CT scan. It is like it could be X-ray tomography, or the CT scan machines which is passing through, where in which the images are. So the image reconstructions is basically, this is what I'm showing in the computer tomography. X-ray is passed through this one, it's captured, and then if I go through a 360-degree capture of the images and it's reconstructed. This is basically modeled through a mathematics called Rajan transcripts. So basically a mathematical model or an integral equations. So where in which you can reconstruct back the images. This is traditionally the electrical and electronics people do this kind of, but a mathematician can also do this research, and many of the mathematicians are also doing this problem. Another one which also I am just working on, the impedance tomography problem, where in which the electrodes are connected and then try to reconstruct the image from that voltage measurement. Another area of research. The fourth area of research, which of course I have expertise, is mathematics of finance. We know that we have assets. We have assets in various forms, like our property, or we have deposited back, or we may have a stocks in some company, right? So when we deposit money in a bank, we know that we will get interest. That's called the time value. When time increases, we will get the money. If you, the 1 month, if you deposit, the interest which we learned from the deposit is less compared to 1 year you invest. So when the time goes, then the benefit is more. And when we deposit money, for example, people might have taken the life insurance from LIC or something. People will get, we will pay the amount, and after sometimes they will give back the amount in a bulk, or the pension schemes which the government has introduced, new pension schemes, where which you will get this amount after retirement in monthly salary, like salary. Now, or if you take a loan from a bank, right, whether SBI or ICICI, if you take a loan, how do they compute all this payment? Because we may have, we take a pay, if we take a loan, then we have to pay an EMI to this bank every month. How do they compute it? How do they come up? It's nothing but mathematics. And if you derive this kind of, if you apply our mathematical skills, it is in the form of equations. You can balance how much balance is left out, or how much principal amount is there, how much we have to pay as a coupon, that means installment, how long you have to pay it. All these things, when we approach a bank, they will say that if you take a 10 years loan or a 5 years loan or a 15 years loan, these are the EMIs you have to pay, and you will be able to close this account with this percentage of interest. For example, if I take 100 rupees loan, then this is the payment schedule they may be showing. Someone who are really interested in the stock price point of the stock, someone might have invested in the stock price. It's nothing but mathematics. You might have seen this kind of graph in the newspaper, like how the stock price is moving. It's essentially mathematics. For example, 80 rupees I invest today, then tomorrow it can be 120 rupees, or it can be 40 rupees. It can go ups and downs. So this process can be modeled through mathematics, or it is traditions for the stochastic differential equations of the form Ts is equal to mu s dt plus sigma. So the stock price modeling is through the mathematics. And understand that one of the heavily paid job in the world is people who work in this finance area. So if you want to become a millionaire, then this is one of the beautiful area, but it's not so easy. You require rigorous mathematics. It's not a simple mathematics. Rigorous mathematics is required to master in this particular area. So another important area which I would like to mention is of the modern demand, the recent demand is data science research. And this is also one of the highly paid jobs in this world. So what is this data science research? Why is there any connections between mathematics and this data science? What kind of expertise is required? As I mentioned earlier, so the mathematics become more powerful when we add computing. In simple language, I could say that this data science research is nothing but maths and computing. So it is a maths, data science is an interdisciplinary area of research. Maths, statistics, and computer science is used. So when I talk about statistics, mathematics, I assume that statistics is part of that. So I don't segregate statistics from the mathematics. Mathematics means it includes the statistics as well. So when we combine this computer science, the computing capability to mathematics, then the data science evolves. So if I want to become a data scientist, I should be very good in maths. I should be very good in computer science. If I have that kind of capabilities, then I will be able to master in this field, and I could say that why it is mathematics is important. When you look at the computer scientist point of view, if you look at the industrial perspective, it's a program. It's basically the program, the languages, algorithms. You translate an algorithms into code. That is what the programming will come into the picture. But when you want to design an algorithm, you need some logical thought, or sometimes it is like a model. Mathematical models are used in the data science world. You convert, so that means a mathematician thinks develop a model. This is what I was telling, that translating a physical phenomena into a mathematics that required logical concept, that required assumptions. And once if you develop a model, then you have to make it into a product. That's what the algorithms and the coding will come into the picture. So the data scientist point of view, if you
Sir, sir, hello, sir. Hello, sir.
മ്യൂട്ടായി പോയി.
Hello, sir. Please unmute your microphone. You are muted now.
hello, are you able to hear?
Yeah, now it's okay, sir. Now it's okay.
Have you heard about what I was talking about, data science research?
Data science, last 30 seconds we lost the audio.
Yeah, so that is what. So the data science is nothing but maths and computer science together. So it is an interdisciplinary area where the high-end mathematics and the computer science techniques are used. So therefore, the opportunities for the modern world is highly demanding. In fact, if you if an industry is hiring for a data scientist, then they will look, if I am comparing a computer scientist and a mathematician with computing knowledge, that industry will prefer only mathematicians with this computer knowledge. Because as I mentioned earlier, they have the special skill compared to any other discipline. So do you think that a career is mathematics? So thank you for listening to me. And if you have any questions, please. Hello. Hello. Are you able to hear?
Yes, sir, you are audible. Any, so now you can ask any doubts or questions to Rajan sir, or you can simply on the chat box, type on the chat box if you have any queries. I think there are no queries. Thank you, everyone. So it is my pleasure, great pleasure, to propose vote of thanks to our resource person, Dr. M.P. Rajan, for beautifully elaborating the role of mathematics in 21st century. He explained different areas of mathematics, its research and career possibilities in simple language. On behalf of St. Bergman's College and Department of Mathematics, I thank you, dear sir, for the very informative session. I am also expressing my sincere thanks to all the participants. I hope this webinar motivate you to learn mathematics more and more. I also want to thank our head of the department, Dr. Shinesi Matthew, coordinator Dr. Ulas Thomas, and all dear teachers. Thank you all once again. Please don't forget to attend the panel of discussion starting at 3 p.m. today. I welcome all of you to the panel discussion, and the meet link will be sent through email. There is a YouTube live also. Okay, thank you all once again. Thank you, dear sir.
Okay.
Thank you, sir.
Very much.
Thank you very
Very
much. Okay. Thank you. Bye.